Good afternoon, students. Myself, Dr. Shalini Hanok, Associate Professor, Department of Electronics and Communication Engineering, ATME College of Engineering, Mysore. Today, I'll be briefing out about how to go about and use virtual lab for learning purpose. Before that, I'll just brief you about what virtual lab is. Virtual lab is an initiative of Ministry of Human Resource Development initiative under the National Mission on Education through ICT. It started with a vision to enrich the learning experience through experimental learning of science, engineering, and technology in a virtual learning environment at preferred pace, place, and period. Virtual Lab ATME College of Engineering is recognized as a nodal center of Virtual Lab NITK Surathkal, and to know about different learning of virtual labs, I am doing this video. So today's experiment, I will be explaining about how to learn certain experiments, and I'm focusing on the subject digital signal processing, and I will be teaching how to see and actually view how things are uh, happening certain topics in DSP, digital signal processing. First, we will deal with sampling theorem. So, sampling theorem, as we have taught in theory, so it is used for conversion of analog signals to digital signals. So here is the definition for sampling theorem. A band limited signal can be reconstructed exactly if it is sampled at a rate at least twice of the maximum frequency component present in the signal. So this is the analog signal, and we have a sampler which samples twice the rate of maximum frequency, and finally we will be getting the digitalized signal of the analog signal. So this concept we are going to view in virtual lab. So let me go to the virtual lab link. We have a Google search engine. Go for virtual lab NITK, and we have this website wherein all participating institutes, that is IIT Kharagpur, IIT Roorkee, IIT Guwahati, and different IIT participating institutions have developed models and they have placed it in the website. So we have to go for the home screen. So in the home, go for the subject you want to learn. Here we are going for electronics and communication, since I'll be teaching electronics and communication subject, and we have different institutes which have provided the materials. So since we are learning about sampling theorem in DSP, let me go for digital signal processing virtual laboratory. And here we have different materials being provided. That is, we have an introduction on the DSP, what is DSP and all, and we have the objective, what we will be learning, and we have different experiments under digital signal processing, and we have a course material provided by IIT Kharagpur. And now we are going for the very first experiment, that is study of sampling theorem, effect of undersampling. So this is the aim of the experiment: how to view the real life analog signal with the oscilloscope, how to set the amplitude, frequency and phase of the signal sources, how to set the sampling frequency. This is the aim of the experiment. So now we will see the theoretical concept of it. So this is a theoretical concept of it. We have an um, we have a sampler which is going to sample. Basically, sampling is used for digitalizing the signal. So that is a theoretical concept. We'll go for simulation. So these are the steps we have to follow, and the block diagram is given here. We are going to see how different measurements can be done. You can on the circuit, and we'll be getting a graph plot wherein you have a y-axis with the voltage input and output. You can see using oscilloscope, and it is varied according to the time. So here are the settings. So we have function generator controls here, and we have oscilloscope controls. Here we have channel 1, channel 2 and dual channel, and the related knobs which will give amplitude as well as the time period controlling here. So now we are going to on once the circuit is on, so we are going to set the amplitude of the wave. So we have to select channel 1. So once the channel 1 is selected, channel 1 is meant for input voltage, and the input voltage of sine wave is given here. To vary the time period, we have to click on this knob and roll it, and so that you will get different um, time periods. So if you want to increase the time period, so this is what it is we'll be getting. So we can now move this knob and get different signals here, and same way here we can move the frequency here and we can get the waveform. So once the frequency is moved, we'll be getting different frequency of waveform. Same here, we'll be getting different amplitude of signals once we are going to at the ranges what you are going to get. So channel 1 we are getting the input voltage. Here in channel 2 we are getting the sampled output of the same. Okay, so now here again we are using this channel 2 knob for increasing and decreasing the amplitude, and here will be increasing and decreasing the time periods. Now to see whether the signal has been sampled, we will use a dual channel, so when you can clearly see the sampled data. So here we will just adjust with the time period voltage so that it matches off. So now after varying the voltages, we have got the blue color line here indicates it is an input signal, a continuous signal, and orange color lines here, discrete pulses, is going to depict the sampled data of the input signal. So you can see the different values here. So these are all sampled data. So after sampling, the analog signal will be converted into digital. So for that purpose we'll be using sampling theorem. Thank you.